Okay, what we're doing here is just working out and showing you how to put the Black-Scholes option pricing model into Excel. There's a couple of examples here, 9b and 9c. They're actually the same example, so I might just go straight to 9c, this one here. Now, Black-Scholes model, really important. Merton, Scholes and Fisher-Black won the Nobel Prize for Economics for this work, so it's a really very important thing for you to understand. We have a whole course about how we use this sort of model to hedge and speculate, derivative price markets and all that sort of stuff. Risk management, financial engineering is all about this stuff, so you really need to know how this works. Now, if you work through these lecture notes here, these pages, finding volatility, it explains to you how to set up a spreadsheet. Now, just following these instructions here, and if you go here, this one here, I'll call this 9C, it's the same thing, I think, or is it 9B? They're the same thing anyway. It explains to you how to set all this stuff up, okay? That's your exercise price, that's the current market price. So you've got an exercise price, I suppose, of $1.50, a market price of $1.48. You're using an interest rate of 10%. You're using that's the time till the option expires, so it's 180 on 365, which is pretty well 6 months out. This is your volatility, which is the pivotal thing. These things are then all used, they're all calculated based upon that. This says that the VCO, value of call option, is 14 cents 0.98 or close to 15 cents. It's saying that's what you should pay for this option that gives you the right to buy this asset for $1.50 when the asset is currently trading at $1.48 and the option expires in 6 months. Now, one of the things that could happen is, of course, options are traded on the market anyway. Now, you've estimated the value of the option to be 15 cents. That actually, the critical thing in all of this is this assumption, this volatility estimate. Now, you've used an estimate of volatility of 0.3. Suppose that you buy your copy of the Financial Review, you look up this option and you find that the thing is trading at 20 cents. Now, if that's the case, that implies that the market does not believe the volatility is this, because that's the only thing that can be different. Everything else in this thing is fixed or known. The volatility is the one you don't know what's going on with. So if that's the case, what are you going to do? Well, you can then try and work out what volatility the market thinks is pushing this option. How do we do that? Well, the easiest way to do that is to try and use the solver. So this is what's known as the implied volatility. The other way you can find the volatility, which again is explained in the notes, is to use the statistical approach, which is you take a sample of data and you try and work out what volatility is what the market thinks, what the previous data says the volatility is, or the standard deviation. Anyway, let's suppose we find that this thing here is trading at 20 cents. So what do? We go to Solver, set the volatility to 20 cents by changing vol. We go solve, and it gives us a volatility of 0.425508. Clearly, that's implying if the market is trading, the option is being traded at 20 cents. It's saying the volatility is not 0.3; it's more than that. Now, if that's the case, then you can then develop a view. If you believe the market, well, then of 20 cents. If you believe your volatility is 0.3 and the market is trading at 20 cents, well, that's telling you that the market is overpricing the option. So you'd get rid of them. Okay, but you may or may not be confident in that. All right, so that's how that particular thing works.